So, hello everybody. I am Christos Ioannidis, and here is Papamichail. We will be presenting our project for the summer quarter, which is basically Linux from scratch. We will get that in a minute. So, the area that we're working on is the area of software security, which is an area that is becoming increasingly more important. Because we today we are used to do much more things with the computer systems. So, for example, we are doing online banking. We share much more information through computers and through the internet. We can think of that 15 years ago we still used to have photos printed. Now we upload them on services. So this is why security is very important, and we must be able to be able to preserve the privacy. So the traditional defense methods mostly come into play as software updates. So we install some antivirus software, which basically we do some updates to the systems to protect it against new attacks. There is also encryption, and in the case of some industries or some corporations, they used to have their own networks installed. Now, what is the problem with these methods? So the attacker, the hacker, so to speak, is always one step in front. So, and software updates do provide some sort of safety, but in order for an update to be applied, the programmer must first find the fault, find the vulnerability, and then fix it, which is basically takes time. Encryption can also be broken, so there have been many cases. The most famous is the web protocol that we used in modems, and still with the wide, so with the spread of wireless networks, so even private networks we cannot be so sure that it can be protected. So the idea is to basically diversify the software distributions. What if we could have a software that behaves exactly the same, but its implementation is slightly a bit different. The implementation is slightly a bit different in the assembly code. For example, what if we could put some NOP instructions or change the way that the stack or the heap behaves among other variants of the same program. So this is what the Secure Systems Laboratory in the University of California, Irvine here has been doing for the past years. And so the best iteration of that project has been the multi-compiler project, which is its goal is to implement the natural diversity mechanism, which protects species by compiler-generated software diversity. What it means is we basically have a compiler that basically compiles the program dynamically and produces different variants of the same software. So, and here where is our project come into play, which Michail will explain to you.
I will tell you a few things about our actual project. We are gonna use the multi-compiler, one of the largest projects in the software security laboratory, so as to build a Linux from scratch distribution using the GCC version of the multi-compiler. We are gonna build the Linux from scratch distribution so as to run an Apache web server with the long-term goal to make to build a secure and efficient server. This is the first task. Until now we have been talking about security, but nowadays not only security is a huge demand that basically servers have and all of today's system. Another big aspect is the efficiency. we are gonna. The huge task of the project is also to measure the efficiency and the overhead which is gonna be produced by the new system that we are gonna build. As for the security part of it, the basic idea is to make the attacker's life very, very difficult. If we, for example, have a large system, a large number of systems running under this Linux this Linux operating system, then if an attacker is able to find a vulnerability and exploit it so as to build an attack, this attack can only affect a small percentage of all servers. So we can guarantee that the largest amount is going to be functioning, and in addition there is no point to make such an effort so as to affect only a very small percentage of your targets. So our project goals come forward with our personal goals in this project. Obviously the final goal is to be able to build a secure and efficient server which can be brought forward, but since working on it, we have understood that there are many goals that we have to achieve step by step in order to reach this final goal. The first of them, which we are working on now, is to gain a better understanding of the Linux system in detail. We are gonna be able to achieve this by building a Linux distribution from scratch and get familiar with all of its components. And the second goal is to study the multi-compiler and understand its functionality. In this detail, we are going to be able to propose ways to optimize or improve its efficiency in our application. If those goals are able to achieve, then we can be some steps forward to achieving the final goal, which is to build the secure server. If you have any questions.
So let me start with the comment. I think very nicely done. I really appreciate the fact that you kind of took what you have as a project and articulated it extremely well. So we kind of understand that you're on the right path, and you laid out the foundation as to how the step-by-step way on how to go around doing it. Extremely well done.
Yeah,
so,
because it's the whole idea that impressed us in the beginning,
yes.
Taking a natural mechanism and try to implement it in software diversity, compiler diversity. Yeah.
No, the idea being that from Mike to you, the transition has happened. Like you internalized it, and you kind of it's laid out it for like a mechanism of doing this.
So the interesting thing is that he uses the word natural, and I actually always talk about artificial diversity.
Quick comment? Yes.
When you recompile for example, the application, is there a guarantee that the security hole will be eliminated from the new distribution? I mean, I think that the different distributions are very similar because they are exactly the same software, right?
But this is what the multi-compiler does. You have the same functionality under binaries which are different from them. So
I think
so the hole doesn't go away. The problem is that the hole is in a different place for every different binary. So they're not generating one new operating system. They're generating a billion different operating systems, and every computer gets a different one.
And each time they compile, it will be a different.
Yeah. So the idea is that the compiler will actually run on the cloud somewhere, and so just imagine that if every iPhone had a different OS, then you would need a billion different jailbreaks to break them all.
Yeah.
Right? So that makes it so each individual one is just as difficult or easy to break as before, but the cost to the attacker goes up very substantially because now you have to break each individual one instead of just doing one and it works everywhere.
So each time a person wants to download a new software, you have to compile it
Yes.
on your own server and then
Yes.
exactly.
You could,
Yes.
or you like
Or-
in binary distributions, you know, like Ubuntu could do that for you.
But I think it's very it's not very cost efficient.
So we can compile Firefox for 1 cent. For 1 cent.
Okay, so we will interrupt it here. Because more things to do now. So, all right. Any
So does
last
the
question?
distributor know where the hole is and what difference is in all the binary?
So this is something that actually the next presentation will go into Mohit's. So we're working on.
I don't know if we have time, but anybody else, any other student has a question. Are there certain types of attacks that this works for and certain types of attacks that it doesn't work for? I would think denial of service is something that is independent of the distribution, right?
First of all, there are some attacks which are very difficult to face, which is the attacks that use your actual code. They are not trying to inject code in your application or your system, but use a certain path of instructions so as to find a vulnerability through a sequence that your own program has. In this way, the attacker will not be able to find or say the exact addresses that those instructions are. So
it's useful for that sort of
this
attack.
is certainly useful for this sort, but for every sort I cannot answer you properly. But this is what in most papers I saw.
Well, you mentioned encryption attacks at the beginning, so this will obviously not do anything for an encryption attack. Right?
Yeah, of course.
If you broke an encryption, it's broken. Right? So it is for a certain type of attack. So, Professor.
Okay, they're just starting off. Get questions for next talk. All right.
Thank you.